Hi everyone, I hope you are doing good. So today in this video we will take a new DSA questions, and the question is maximum path sum from any node. So let's understand the question first, and then we will discuss the solution, and then I will implement that solution into the C++ code, and then we will have a dry run. Right? So let's start. So the problem is given a binary tree, one binary tree will be given, and the task is to find the maximum path sum. Right? It is saying the path may start and end at any node in the tree. It means the path can start from any node and it can end at any node. Right? So let's take some examples here. So the first example given is here we have this binary tree, and in this binary tree we have to find the maximum sum path or path sum, you can say, right? So where, for example, here this one, so this is the maximum sum path, correct? This one. How? So the total is 22, 10, 10. This is 42, right? If we include this one also, then it will basically if we add this minus 25, then that would be the less than 42, correct? Because we have to subtract then, correct? If we include 4, then also, because then we have to subtract minus 21 from 42, right? And instead of 20, if we include this 1, correct, this 1, then this path would be 10, 10, 2, 1, that is 33 only, sorry, 23 only, correct? So this would be the maximum path. So I hope you are getting it. We have to find the maximum path sum, right? Or we have to find a path, the sum of that path would be maximum in that given tree. Let's take another example here. So this is the another example. So here this is the binary tree, right? And here we have to find the maximum path sum, right? We have to find a path, the sum of that path would be maximum. So if we take this path one, right? So this one. So this one would be this is 10, 4, 14, 17. This would be minus 3. This is not maximum, correct? This is not maximum. So now take another path here. If we take this one, right? So this is 20, 11. That is 31 minus 17, right? So it would be 17, 14 हो जाएगा, right? So it would be 14 plus 14. But now if we exclude this one and we keep this till this one only, right? So here if we keep these two nodes only, this path only, then this would be 31, right? So 31 is greater than 41, correct? So we can say this is the maximum sum path or path sum, correct? And the output would be 31. So I hope you are getting it. Basically we have to find a path, the sum of that path would be maximum in that given binary tree, right? So this is the only path, using that we can make the maximum sum, correct? So I hope you understood the question now. So now let's think about the solution. What could be the solution here? And comment below the video and share your solution. So let me share my solution with you. So what I thought is, what we can do, we can traverse the tree to leftmost, right here. For example, here. So what I will do, I will go to leftmost tree. So here, right? And then I will say, if the root is null, then we will return 0. The sum of the path is 0. There is no node, correct? So here, no node, so it will return 0 here, right? This side also, no node, right? So it will return 0 here, correct? So this way, and then I will check left and right here, and so I would create basically two scenarios. One is, so for example, we have this two node, right? So one scenario is we have to include this like maximum of these two left and right, right? So for example, here this is the maximum, so we say we have to include this one, correct? Other scenario is we have to include both, because the path could be like this one only, right? 2, 1, 3. So here, for example, here we have the maximum is 2 and 3, that is 3, and the root is 1, right? So 1, so it is making 4. But if we include the left one as well, in that case it would be 2, 1, 3, that is 6, right? 2, 1, 3, that is 6, and 6 is the maximum, right? So or result should be 6, correct? So these are the two scenarios, and whenever we if this one node, this first root one, it is having one parent node, for example, right? This one parent. So in that case we cannot pass this 6 here. Here we have to pass only this basically 4, right? Why? Because from here the path could be either we can go here, right? And then from here, this node, we can go either left or right. So that is why what we will do, we will take the maximum and then we will add that maximum to root, and then we will pass that maximum. For example, here, this is the maximum, right? So what we will do here, 1 plus 3, that is 4, right? And 4 we will pass here for the left call. So that is what my logic behind this solution is. So let me explain it here. So I have added like I am calling this helper function solve max sum. Here I am taking one res result. So here in res I have initialized it with int minimum, right? And here in res we will store the or maximum path sum value, right? Whatever the maximum sum we can make, that we will store in the res, right? So initially it is integer minimum value, correct? And then here if root is null, in that case just return 0, right? And I'm taking it as a reference, so that whenever we get the maximum we will update it there itself, correct? And then I'm going left here. I'm calculating the left value, and here right value, and here left value, right? So root arrow left and we are passing res here, root arrow right and we are passing res here, right? So what we will do here in this case, so we come here, right? Then here, correct? And then from here to we call here also, right? Root arrow left, that is null. So in that case, in case of null, we are getting 0, correct? So here the left of this would be, so here let me write here, left of this would be 0, right would be 0, because once we go for left, then we will come back and then we will call for right, right? Root arrow right, comma res. Root arrow right is, this is the root in this case. So root arrow right is null, so it will come here, and this right would also be 0. Then we will calculate the temp, right? And the temp is the maximum of left and right, and if both are in negative values, in that case we will say 0 would be the temp value, because then in that case, if so, let's see here, this is my root, right? And here we have minus 10, and here we have minus 20, right? So in this case, what would be the maximum sum path? Only 20 only, correct? 20. Why 20? Because if we include this left, then it would be 10, right? So if this is 20, if we do not include any, right? And if I include left, then it would be 10, and if I include right, then it would be 0, right? And if I include both, in that case it would be minus 10, correct? So our result should be this 20 only. So in that, and what would be the scenario? In that case we do not, like, we cannot include left or right, correct? So that is why I am saying here I have added 0 here. So take left and right, the maximum of left and right, so that would be minus 10 is the maximum, right? So maximum of minus 10 comma 0, that would be 0, correct? So here we are taking the temp would be 0, right? The temp would be 0, correct? And then what I will do, I will say now I will calculate, I will update the res, as well as I will pass that this value to the upper level, basically parent, right? So one scenario is I can include left and right both. One scenario is I can include the maximum of left and right, right? And maximum of left and right we have stored in the temp value, right? So this root arrow data plus left plus right, this is the one scenario. So this root arrow data plus left plus right, This is one scenario. Other one is root arrow data plus temp. What temp is having? Temp is having the maximum value of left and right. If both are negative, then it would be having 0. Correct? So here temp is 0 and root arrow data is basically 20. So 20 plus 0, that is this would be 20, right? And here root arrow data plus right. Left and right is also having 0. Root arrow data is 20. So here also it is having 20, right? And so, and RES is having integer min value, right? Minimum int min value, correct? So now we can update this RES with the 20. So here at this node, RES got updated to 20, correct? And here we are returning now, as I told you, right, we cannot return this RES value here because RES might include left and right both, correct? So that is what we can return from here. We can return only root arrow data plus maximum value of left and right, whatever we are getting from left and right, right? So here left and right maximum temp, then that value we are storing in temp, right? So what we will do, root arrow data plus temp, that we will return to the parent node, right? So temp is having 0, so root arrow data we will return. So from here we will return here only root arrow data plus temp, that is 20, and that we will store in the left part because this here we are coming from the left, right? So here left would be 20, right? Right we will update, and then RES is 20, correct? And then temp we will calculate, right? So now let me clear this. Okay, so now we are here. Now so after this we are coming from left and we are this node, right? And after this we will call the right side, right? This call we will do, and here we will go there, and root is not null, this is not null, so it will call for left for this node, right? Left, from left it will come back and it will say it is 0, this side also 0, right? It means for this node left is 0, right is 0, right? And temp is 1, correct? And RES for this one, RES currently is 20, right? So here left and right is 0 0, so temp would be 0, and then here if we include left and right both and root arrow data, that would be 1, and here also that would be 1, and RES is 20, so RES would be 20 here also, right? We will not update RES because 20 is maximum greater than the 1, right? And from here what we will return, root arrow data plus temp. Temp is 0, root arrow data is 1, right? And this value will be stored in the right, right? So here let's update right would be 1, correct, for this node. Now we are done from here and we will return from here. Now we will return from here to parent, right? Parent call, and here we will say left value would be whatever the value we get from here, and we are returning from here root arrow data plus temp, and at this place we will calculate temp. So temp is left, the maximum of left and right, so left is 20, right is 1, so maximum is 20, so temp would be 20 here, correct? Temp would be 20. Now update the RES, so maximum of RES is 20 now, and root arrow data plus left plus right, so left that is 20, right is 1, and root arrow data is 2, so it would be 2 plus 20 plus 1, that is 23, right? 23. And the other is the include only maximum, so that is root arrow data 2 plus maximum, that is 20, right? Temp is 20, right? So 2 plus 20, that is 22. So now 23 is the maximum, right? So just update the RES with 20, and RES is 20, right? So maximum of among these three is 23. So let's update the RES. So RES would be now 23, right? So here you can say RES is 23, correct? And here left we will return root arrow data plus temp. So temp is 20, right? So 2 plus 20, that is 22. So left would be 22, right? Right we will calculate, and temp we will calculate, right? So now this is this, and then we will call for the right here for this one, and for this one, then for this node we will call from here, we will come here and we will call the left call for this one. So here left would be 0, right? At this place left would be 0, we will come here and then we will call for right, and for this node we will call for left here, this one, and here also left would be 0, right would be 0, right, temp would be 0, and here res we have 23, correct? So now from here, once when we return here, then we will return that here left would be 3, correct? And we calculate, we will go for right here, so this one, and here for this node we will call left and right, and then we will calculate this, do the calculation of this one. So here left would be 0, right would be 0, temp would be 0, and res would be 23, right? So now for this node we will calculate the right. So right would be root arrow data, this one, plus temp would be 0, so 4, correct? And now we are at line number 105. So after 105, what we will do, we will say temp, we will calculate temp, so left and right, so maximum is 4, so right, so here temp is 4, correct? And then we will calculate, we will try to update the res, so res is 23, right? Res is 23. So let me take the green, yeah. So res is 23, this is 23, root arrow data plus left and right, so it would be 7, this, it would be minus 18, right? So this value would be minus 18 if we include left and right, and if we include maximum only, in that case it would be minus 21, right? So here the maximum is 23 itself, so we will not update anything, res would be 23 only, res would be 23 only, right? And we will return from here, what we will return from here, root arrow data plus temp, right? So root arrow data is minus 24, temp is 4, so it would be minus 21, right? So here right would be minus 21, correct? And for this node we will calculate the temp here. So temp would be the maximum of left and right, so that would be 0, right? 0 is the greater than minus 21, correct? Now try to update the res, so res is 23, and root arrow data, that is 10 plus left and right, left is 0, right is minus 21, so it would be 10 minus basically 11, minus 11, and then root arrow data plus temp, so that would be 10. The maximum is 23, so we will not update res would be the maximum itself, right? So here also res would be 23, right? And from here we will come back to the root and return, right? So here what we will return root arrow data plus temp, so temp is 0, right? So we will return 10 only, and that would be stored in the right side, right? So here right would be for this node 10, this one 10, right? And then now we will calculate the temp here. So temp would be the maximum of left and right, so left is 22, right is 10, right? So this temp would be 22, because 22 is greater than the 10, right? So now try to update the res here, right? So currently the res is 23, this is 23, and the root arrow data plus left plus right, so root arrow data is 10, left is 22, right is 10, so it would be 42, right? So this becomes 42, right? And root arrow data plus temp, so temp is 22 and root arrow data is 10, so it would be 32, right? So the maximum of these three is 42, so we will update the res, so this 23 now, then we will update it to 42, correct? And then we will return from here. From here we will return to the main functions. So we are returning the root arrow data plus temp, but we are not caring about this value, we are caring about this res resultant value, and that would be our solution, that is 42. So I hope you are getting it. It is not that much complex. You can easily understand it, right? So here what you have to keep in mind, you have to go left, 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 right, first, and then what you have to do, you have to there are two scenarios. Either you can include the left or right, the maximum of these two, or you can include if you are on the top of the root node, then you can take the left and right both as well, right? So that is what we are doing here. So this temp value we are calculating so that we can include the maximum value, either left or right, and then we can pass that value to the parent node, right? And if we want to include left and right both the directions, because the path can start from any node and it can end at any node, right? That is why here, and we are taking maximum value, we are always updating the RES with the maximum. If RES itself is maximum, then we are not updating that, correct? So I hope you got it. If you have any doubt, query, then you can comment below the video, and if you want or need this code also, then also you can comment below the video. I will provide the link or code, right? So that's all for today. Yeah, see you next time. Till then, keep learning and keep exploring.